This video is for November 3rd and or November 4th. We're looking at trigonometric expressions still, and we're trying to simplify those expressions using different identities. We also need to look and see how we can factor these expressions and how that actually helps us simplify some expressions. The day before this was November 1st and 2nd. I'm not going to post those notes online. They're not actually directly tied to the content. What we're doing here is we're simplifying the expressions. So we're using factoring techniques on this front page, which is what we talked about on November 1st and 2nd. I'm going to summarize, paraphrase those here, and hopefully that'll help. But like this first expression here, what we want to simplify it, write it in a more simplified manner, if you will. So what we should notice right away is that here we have a sign in both terms. If that's the case, if we have a quantity in both terms, I mean, again, it could be helpful, it might not be, but what would be helpful here is if we have a sign in both terms, let's go ahead and factor that quantity out. So for example, if I have 2xy plus 7y, I have a y in both terms, I can factor that y out and just have 2x plus 7. We're reversing the distributive property here. Same thing here, I have a sign in both terms. I'm going to factor that sign out. Now here, if I factor sign out of this first term, I'm left with cosine squared x. And here in this term, so minus, in that term, if I factor out sine, we're really dividing by sine. I'm left with 1. Much better. Reason being is you're reversing the distributive property. So if you were to multiply this, sine times cosine squared will give us sine cosine squared. Sine times negative 1 would be negative sine. So we're reversing the distributive property here. Now it's going to be really helpful to have the identities out. Different fundamental identities out, because from here we know sine squared x plus cosine squared x equals 1. Well, here if I want cosine squared minus 1, so if I subtract 1 from both sides, then we would get sine squared x plus cosine squared x minus 1 equals 0. So there I have my cosine squared minus 1. Now if I subtract sine squared from both sides, this becomes cosine squared x minus 1 because I subtracted it, but I also have to subtract it here. So that would become negative sine squared. So we manipulate this identity. This is a Pythagorean identity, this identity there. We manipulate that identity to get cosine squared minus 1. We see that this is the same as sine squared, or sorry, negative sine squared. And so what we can say is the sine, we didn't do anything to the sine, that sine stays there. But we can say that cosine squared minus 1, which is here, that is equivalent to negative sine squared. They are the same. So that means I can replace cosine squared minus 1 with negative sine squared x. And now if I multiply this, again, similar to like x times x squared, that's x cubed. This would, with the negative still there, negative sine squared times sine will give us sine cubed. And that's what this simplifies to. So here we notice sine occurs in both terms. If you need to pause at any time, please do so. You have a sine in both terms. We can factor that out. From here, we can manipulate this identity. If we manipulate this identity, we find that cosine squared minus 1 is negative sine squared. We can replace that there, multiply, end up with negative sine to the third. I'll probably have to do 3 videos. Let's go on to the second problem here, just because they take a little bit longer. Now here, we notice we have secant to the 4th minus tangent to the 4th. But if we look at our identities, it only has something squared. So it'd be great if we could do something here to work with just squares. And it would be ideal, and we can do it. What we can say is this is secant squared x. That quantity, we can square that. So square, if we square a square, that would, you multiply the exponents, gets you to the fourth. Minus tangent squared x squared. So now that we have this, what we have is a quantity being squared minus another quantity being squared. This is nothing other than a good old-fashioned difference of two squares. Someone might come on the announcements in a second, so I apologize if a loud voice comes on. And the way we can factor this now. Well, the way we factor this is you have this quantity. The quantity that's being squared here is actually secant squared. The quantity being squared here is tangent squared. So the first quantity, secant squared x, then minus the second quantity, tangent squared x. Now if it's a difference of two squares, we can do this minus that times secant squared x plus tangent squared x. Now I would actually recommend pausing and foiling this, right? First, outer, inner, last. I would foil this and see if you end up back here. You should. This is how a difference of two squares works. And now, also you need to pause, please do so. Now I see I have secant squared tangent squared, secant squared tangent squared. I also know this identity. I'm going to write it over here. Make sure I'm writing it correct. Tangent squared x equals secant squared. We have this identity as well. And if we can, it would be great if we can manipulate this identity and get one of these forms, which we can. We have a positive secant squared. I want negative tangent. It's positive here. But if I subtract tangent squared from both sides, try to write small on this pen. I know it's on the side because we're going to keep working there. These will go away. You have 1 is equal to secant squared x minus tangent squared x. Which, hey, that's what we want, right? That's what we wanted here. We wanted secant squared minus tangent squared. We have it. Secant squared minus tangent squared. This whole parenthesis set here is just equal to 1 due to this identity here. And so what we would have is 1 times secant squared x plus tangent squared x. And we know that anything times 1 is itself, so we have secant squared x plus and that's what this was simplified to. These are a little, excuse me. These can be tricky because we need to identify this as a difference of two squares, rewrite that as a difference of two squares. And once we do that, then we can factor using what we know about difference of two squares. We see that this is 1. This we could try to work this out and get secant and tangent both positive on one side of the equation, but it doesn't work. And so what it simplifies to is secant squared plus tangent squared. I'm going to pause there for this video. On the next video, we'll do these two and probably 1 or 2 on the next page, and I'll probably have a third video as well.